Exercise 7.11, question number 7. Integration 0 to 1 x times 1 minus x power n dx. We use the property 0 to a fx dx equals 0 to f a minus x dx. It will become 0 to 1 minus x times 1 minus x power n dx. Here x is replaced by 1 minus x. Now 0 to 1 minus x, and this will become x power n dx, because 1 will cancel out and minus sign will make this minus x to plus. Okay, so this becomes 0 to 1 and x power n dx minus integration 0 to 1 x power n plus 1 dx. Now you can easily integrate by using the formula integration x power n dx equal to x power n plus 1 upon n plus 1, and then put the limits. Question number 8. 0 to pi by 4 log 1 plus tan x dx. Here again we use property 0 to a fx equal to 0 to a f a minus x dx. So the question is I. So I equals 0 to pi by 4 log of 1 plus tan pi by 4 minus x dx. If you remember, tan a minus b is equal to tan a minus tan b divided by 1 plus tan a tan. So you can use this. It will become I equals 0 to pi by 4 log of 1 plus tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x whole dx, which will become 0 to pi by 4 log of tan pi by 4 is 1. So 1 plus 1 minus tan x divided by 1 plus tan x dx. If we take LCM, it will become 0 to pi by 4 log of inside bracket 1 plus tan x plus 1 minus tan x dx divided by 1 plus tan x. Here tan x will cancel out 2 upon I equal to 0 to pi by 4 log of 2 upon 1 plus tan x dx. We can apply the property of log, that is log m upon n will become log m minus log n. So it will become I equal to 0 to pi by 4 log 2 dx minus 0 to pi by 4 log 1 plus tan x dx, which is question itself. So we can write it as I minus I and this thing. So here there is I, this is also I, so this will become 2I. So we will get 2I equal to 0 to pi by 4 log 2 dx. This is constant and dx will give x. So we will get 2I equals log 2 times x with the limits 0 to pi by 4. So it will become I equal to 1 by 2 times log 2 times, this will become pi by 4. So this 2 and this 4 will become pi by 8. So the way I equals pi by 8 log 2. Now let's go to next question. Question number 9. Question number 9 says integration 0 to 2 x root of 2 minus x dx. We apply property 0 to a fx dx equal to 0 to a minus x dx. So this is I. So I equals 0 to 2. In place of x, we are going to write 2 minus x. X is replaced by 2 minus x. So this will become 2 minus x root 2 minus 2 minus x dx. This will give 2 will cancel out and x will be left. So we will get 0 to 2, 2 minus x times root x dx, which will be equal to 0 to 2, 2 root x dx minus 0 to 2, x power, x root x means x power 3 by 2 dx. Now you can integrate because it is simple and then put the limits. Now let's go to question number 10. Question number 10 says 0 to pi by 2, 2 log sin x minus log sin 2x dx. N log m equal to log m power n and log m minus log n equal to log m upon n. These two properties we are going to make use. So it will become 0 to pi by 2 log sin square x minus log sin 2x dx. Then again we apply second property 0 to pi by 2 log sin square x upon sin 2x dx, which will be equal to 0 to pi by 2 log sin x into sin x dx divided by 2 sin x times cos x. So 1 sin x will cancel out. And then tan x by 2 will be left. So we get I equals 0 to pi by 2 log tan x divided by 2 dx. Now we write it further 0 to pi by 2 and this will become log tan x dx minus 0 to pi by 2 2 sorry 0 to pi by 2 and here log m upon n log m minus n log 2 dx. So it will become first term will become 0 that we are going to do. Suppose we take it I1 So it will become 0. And from second one, we will get log 2 and dx will give x limits 0 to pi by 2. So this will be minus log 2 times pi by. So let's prove this term first. Our answer will be this, but we have to check whether this is 0 or not. So we consider I1. I1 equal to 0 to pi by 2 log tan x dx. We apply the property 0 to a fx dx equal to 0 to a f a minus x dx. So I1 equal to, suppose this is equation number 1, 0 to pi by 2 log of tan pi by 2 minus x dx. This will give 0 to pi by 2 log tan pi by 2 minus theta gives cot theta, cot x dx. Suppose this is equation number 2. Now, if we add 1 and 2, so 2I1 equal to 0 to pi by 2 log tan x plus log cot x dx. Using property of log m plus log n equal to log m upon n, we will get 2I1 equal to 0 to pi by 2 log of, here log m plus log n becomes log m into n. So it will become tan x multiplied by cot x dx. So tan x into cot x will give 1. So 0 to pi by 2 log 1 dx. And we know log 1 is 0. So this entire integral will become 0. Hence our answer will be this. Now let's go to question number 11. Question number 11 says integration minus pi by 2 to pi by 2 sine square x dx. Here we are going to use another property. So we consider fx. Suppose this is sine square x. If we change x by minus x, so it will become sine minus x square. So this will be minus sine x square. That is sine square x. It means fx equal to f of minus x. Hence, sine square x is an even function. And in case of even function, the rule is there, integration minus a to a fx dx equal to twice of 0 to a fx dx. So this property we can apply here. So it will become twice of 0 to pi by 2 sine square x dx. Now, if you remember, sine square x equal to 1 minus cos 2x divided by 2. So that property we can apply here. So it will be twice of 0 to pi by 2, 1 minus cos 2x divided by 2 dx. This 2 will cancel out, and then we will be left with 1 minus cos 2x dx. We can integrate. So 1 will give x, cos 2x will give sine 2x divided by 2, 0 to pi by 2. Now we can split the limit x 0 to pi by 2. minus 1 by 2 sine 2x 0 to pi by 2. So now we put the limits. So it will become pi by 2 minus 0 minus 1 by 2. When we put sine here in place of x pi by 2, so it will become sine 2 times pi by 2, that is sine pi, and sine pi is 0. Then we put 0, so sine 0. In both the cases, it will be 0. So our answer will be pi by 2. Now let's go to question number 12. Question number 12 says 0 to pi x dx divided by 1 plus sine x. Suppose this is r. Here we are going to make use of the property 0 to a fx dx is equal to 0 to a f a minus x dx. So I equal to, we have 0 to pi x dx divided by 1 plus x. Now we apply the property. Suppose this is equation number 1. I equal to 0 to pi in place of x. Here x is being replaced by pi minus x. So pi minus x dx divided by 1 plus sine pi minus x. Sine pi minus x is sine x. So I equal to 0 to pi minus x dx divided by 1 plus sine x. Equation number 2. If we add equation 1 and 2, we will get 2I equal to 0 to pi. Denominators are same, so 1 plus sine x. In case of numerator, here there is x, here there is pi minus x. So only pi dx will be left. So what we can do, we can write it as I equal to 1 upon 2 integration 0 to pi dx divided by 1 plus sine x. Now we can multiply and divide by 1 minus sine x, 1 minus sine x. So our next step will be I equal to pi by 2 integration 0 to pi 1 minus sine x dx divided by 1 plus sine x times 1 minus sine x will give cos square x, because 1 minus sine square x is equal to cos square x. So we divide it separately, pi by 2, 0 to pi 1 upon cos square x dx minus pi by 2, 0 to pi sine x dx divided by cos square x. So it will give I equal to pi by 2 integration 0 to pi sec square x dx minus pi by 2 integration. Here we can put cos x equal to t, cos x equal to t minus sine x dx equal to dt. So here there is minus sign and sine x dx. So we can write plus, this is dt divided by t square. And we can change the limits also. When x equal to 0, then cos 0 will be t equal to 1. So this is 1. When x equal to pi, here upper limit, when x equal to pi, then cos pi is minus 1 and t equal to minus 1. Pi by 2, 1 to minus 1 dt upon t square. Here, the first term will give tan x, so pi by 2, and this will give tan x limits 0 to pi, plus this will become pi by 2, and integration of t power minus 2, so t power minus 2 plus 1 upon minus 2 plus 1, that is t power minus 1 upon minus 1, that is minus 1 upon t. So this will give minus 1 upon t, limits 1 to minus 1. So if we put here t equal to minus 1, so let's write it clearly. So it will become pi by 2 times tan pi 0, tan 0 is also 0, into 0, plus this pi by 2, minus sign we can take out, then it will become here 1 upon minus 1 minus 1 upon 1. So this will give minus 2 term here, and there is already minus sign. So minus pi by 2 into minus 2, which will give pi. And that is our answer. Let's see question number 13. Question number 13 says integration minus pi by 2 to plus pi by 2 sine power 7x dx. Now let's check whether sine power 7x is odd or even function. Then we will apply the property. So fx equal to sine power 7x. If we replace x by minus x, it will become sine power 7 minus x. So this will give minus sine power 7x. Since f minus x equal to minus half fx, so sine power 7x is an odd function. And for odd function, minus a to plus a fx dx gives 0. So it will give 0. So you have to show this working and then you will write the result. Now let's consider next question. Question number 15. Question number 14 says 0 to 2 pi cos power 5x dx. Here we can apply property. Since length of the video is increasing, so I will do this question in next video. Thank you for watching.